Hello everybody, this is Mr. Walters and we are transforming copper. We're going to transform copper solid into several different compounds and then re-transform it back into solid metal. So here's a little bit of copper strips and there's a little bit more here. So the first thing we're going to do is place the rest of the copper into our 250 milliliter flask here. And then we're going to add a wicked strong nitric acid, which is going to oxidize that copper. And once the copper is oxidized, we'll have copper double positive ions floating around in solution. This is going to be the first step of our transformation. Let's add the nitric acid, a strong oxidizing agent, and let's oxidize that copper. We're also going to see a brown gas produced and released, and that's nitrogen dioxide. That brown gas is a pollutant, and just as an aside, that brown gas is a contributor to acid rain, which will be the topic of another video. Notice we have this reaction occurring in a fume hood, and you can see the brown nitrogen dioxide gas that's being generated, and the fume hood is taking that out of the chemistry lab here. Trying to make sure all the acid gets all the little pieces of copper. So I've got a little bit of nitrogen dioxide gas that's still present in my reaction vessel. I'm going to add just a little bit of deionized water or distilled water. And what that's going to do, it'll dilute out the acid some, so it won't be quite as strong as acid, although it's still going to be quite dangerous. But it's also, that water is going to react with the nitrogen dioxide, and it's going to remove it from its gaseous form and produce an acidic product that's dissolved in the water. So let's do that. So I'll add a little bit of that. And here we go. So I just added a little bit. I'm now swooshing it around, and a lot of that nitrogen dioxide is now dissolved. And also, look at what I have. I've got a copper nitrate solution now, and that color is indicative of copper double positive ions. Reminds me of copper sulfate is this sort of pretty blue. Copper nitrate solution the same way. Again, copper double positive ions produce this colored solution when it's in aqueous form. All right, so here's our reaction of interest. We have solid copper. We've added concentrated, and I do mean concentrated, it's over 10 molar nitric acid. And we get the products, we get a copper nitrate solution. So you get copper ions hydrated by water, plus you get nitrate ions hydrated by water, so that's why they're aqueous. Of course, we saw the brown nitrogen dioxide gas produced. So that's a pollutant, and that's one of the gases that contributes to acid rain. Of course, we also have some water produced. So here's the products of the reaction. Now I want you to realize the final solution, we have aqueous copper nitrate. Now notice the copper ions give the solution its bluish color. We also have nitrate ions, because that's in excess. So we have plenty of nitrate ions flowing around. those nitrate ions are colorless. It's the copper double positive that's giving this pretty blue solution. Don't forget though, the pH is very low, and we have large amounts of H positive as well. Okay, here is our copper nitrate solution again, and I wanted to illustrate the hydrogen ion concentration. The pH is less than 1.0. This is highly acidic, so we have a large amount of H positive ions relative to hydroxide ions. So at this pH, we have those numerous H positive ions, also called hydronium H3O positive ions. Notice in much greater amounts compared to the blue hydroxide ions. If the pH were 1, we would have 1 times 10 to the negative first big M moles per liter of H positive ions, and we'd have 1 times 10 to the negative 13th moles per liter of the hydroxide ions. And again, notice that final solution. These are in solution as aqueous ions, so there is an AQ in parentheses around all of these ions. Plenty of water in here as the solvent. Notice the excess nitrate came from the excess acid. So here's the two reactants. Again, the nitric acid is in excess. We did that to ensure that all the copper was oxidized. And we have no more solid copper present. It's all hydrated double positive copper ions. And there we have it, that final solution. Now the next step, we're going to add some other reactants which are going to precipitate out the Cu double positive ion. That's the next step.